When the stepper is operating in open loop mode, the valve will only respond to changes in the control input to the device. Changes into the feedback input are ignored. Through a test application in our voltage current controller device, we can supply different test signals to the stepper valve. Normally, these signals would be generated or provided by a PLC or other circuit. Here, I am modifying the feedback signal provided to the stepper, but keeping the control input to a minimum. Changes in the feedback signal have no effect on the operation of the device in open loop mode. Setting the control voltage to 4.5 volt in open loop mode will cause the device to open. Here we see the stepper opening. Now we're going to make sure that our feedback signal is set to 0.5 volt over here, and we are going to put the device into closed loop mode. The closed loop signal is a high 12 volt or 24 volt signal, depending on the specified voltage of the device, that is provided on the pin 5 of the switch connection found in the onboard M12 connector, and this will cause the stepper to go into the closed loop mode. When operating in closed loop mode, the stepper valve compares the difference between the control and the feedback signals. When the control signal is higher than the feedback signal, the stepper valve will open the valve to try to increase the feedback signal. So right now we've got our control at 4.5 volt and our feedback at 0.5 volt, and we're in open loop mode. But I'm going to switch the device into closed loop mode, and because the control signal is higher than the feedback, the device will try to open more to increase the feedback signal. So now our device is opening to try to get to bring the feedback signal up. I've hit this button to make the feedback signal go to a value of 4.5 volt. If the control and the feedback signal are within range of one another or in hysteresis, the device will be in a stable position and the LED ring will light yellow. The dither or hysteresis is adjustable via the D potentiometer and can range from approximately 0.1 volt to 1.0 volt based on the setting of the pot. If the feedback signal increases above the control signal, the stepper valve will attempt to close the valve to decrease the flow signal. Here we'll increase the feedback signal. Now we can see that the stepper is trying to close. The further apart that the control and feedback signal are, the more the stepper valve will attempt to open or close the valve. If the control and feedback signals are not very far apart, the valve will take smaller motions to open or close the valve. So I'll just increase it slightly. You can see there's smaller motions. We'll try to open the valve now, go the opposite way. Increasing to a larger difference.